All right, today we are talking about trigonometric ratios in right triangles. So you're probably familiar with SOHCAHTOA. SOHCAHTOA is an acronym to help you remember your trig ratios. Sine of theta, so that symbol is theta. It's a Greek letter that we use to represent angles. Theta is your angle right here. So sine of theta, this particular angle, is the ratio of the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then cosecant, secant, and cotangent are the reciprocals of that. Cosecant is the reciprocal of sine. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. All right, so find the exact value of all 6 trig functions. You're given this right triangle with only 2 out of the 3 sides given. So the first thing you want to do is do Pythagorean theorem to find this missing third side. So 6 squared plus, let's call it b squared equals 10 squared. 36 plus b squared equals 100. Subtract 36 from both sides. B squared equals 64, so you take the square root and you get b equals 8. We know it would be plus or minus 8, except you can't have a side of a triangle that's negative, so it's only going to be positive 8. Okay, so now we need to find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. All right, sine of theta is opposite over adjacent. We now know that our opposite side is 8. This is opposite, this is the adjacent, and this is the hypotenuse. So opposite over hypotenuse is 8 over 10, which reduces to 4 over 5. Cosine is adjacent over hypotenuse. Cosine is 6 over 10, which reduces to 3 over 5. Tangent is opposite over adjacent, so 8 over 6, which reduces to 4 over 3. Cosecant is the reciprocal of sine, so cosecant is 5 over 4. Secant is the, whoops, typical Miss Briscoe, dropping her marker. Secant is the reciprocal of cosine, so it's 5 over 3. And cotangent is the reciprocal of tangent, so it's 3 over 4. The next type of problem would be where you're given the value of one trig function and you need to find the value of 2 to 3 other ones. So we know that in our right triangle, whatever it is, cosine of theta equals 2 over 5. We know that cosine is adjacent over hypotenuse. So we're going to draw a right triangle, pick one of the angles that's not the right angle to be theta. I'm just going to pick this one. So the side adjacent to theta is 2, and the hypotenuse is 5. So we need to figure out what is this third side. We're going to do Pythagorean theorem. Let's call it b. 2 squared plus b squared equals 5 squared. 4 plus b squared equals 25. Subtract 4 from both sides and you get b squared equals 21. We take the square root of 21 and that doesn't simplify. So this side is square root of 21. So that's the opposite side. That's the opposite side. So if I'm looking for, this is opposite, this is adjacent, and this is hypotenuse. If I'm looking for sine of theta is opposite over hypotenuse. Sine of theta is now root 21 over 5. And tangent of theta is adjacent over hypotenuse. It would be 2 over 5. So we took one trig function, set up a triangle, did Pythagorean theorem to find the missing side, and then found the 2 remaining trig functions. Okay, now you're going to try this problem on your own. Secant of theta is equal to 5, and you want to find cotangent of theta and sine of theta. Keep in mind, or not keep in mind, to help you, secant is the reciprocal of what? That's a good hint to start with. Secant is the reciprocal of which trig function. So pause your video, attempt this problem, and then I'll reveal the answer. So pause your video and try the problem. All right, so here's the answer to that u-try problem. So first off, secant is the reciprocal of cosine. So if secant of theta is 5, cosine of theta is 1 over 5, which is adjacent over hypotenuse. So that's how we labeled our triangle, adjacent over hypotenuse, 1 over 5. Do Pythag, and you get that the opposite side is 2 root 6. So cotangent is the reciprocal of tangent, so it's adjacent over opposite, 1 over 2 root 6. But you can't leave a radical in your denominator. You have to rationalize your denominator to get square root of 6 over 12. And then sine of theta is opposite over hypotenuse, 2 root 6 over 5. Right, next example is cosine of 2 pi over 3. 2 pi over 3 is 120 degrees. So it will be in the second quadrant. So if this is 120 degrees, and all the way across is 180 degrees, this would be 60. So now we can draw right triangle. This is 30. Across from the 30 is 1. Across from 60 is root 3. Across from 90 is 2. Except we are now on the left side of our y-axis. So all these x values over here are negative. So this is actually -1. And this makes sense because cosine is negative in the second quadrant. So we have our right triangle created. Now we're trying to find cosine of 2 pi over 3. Cosine is adjacent over hypotenuse, -1 over 2.